Hello, pre-calculus students. This is Mrs. Raposa here, and this is your hybrid out lesson on section 2.4. And the objective is to find maximum and minimum values for particular functions. If you didn't get a copy of these notes the last time you were in class, you can either print a copy at home and write on them, or you can just take notes on a separate piece of paper. Let's get started with example 1. Okay, example 1 in our 2.4 notes is a maximization problem. I need to figure out how to make a rectangular dog pen against a barn so that I can get a maximum area out of this. So obviously I'm going to use all 60 meters of the fencing to maximize the area. So let's first express the area of this pen in terms of x. I only need to make 3 walls because the 4th wall that encloses the dog pen is against the barn. So 3 walls with 60 meters of fencing, and I know that the area of the area of this dog pen is going to be the length times the width. But I need to get that all in terms of x, okay? Everything needs to be in terms of x here. Well, if it's a rectangular pen, x feet is here, or x meters, I'm sorry. That x meters is also going to be here too because it's a rectangle. Opposite sides are the same length. If x was 10, if this was 10 meters and this was 10 meters, that would be 20 meters of fencing already used up. That would only leave me 40 here. So I can express this side of the barn, this side of the dog pen in terms of x. If this was 5, then this would also be 5. 5 meters of fencing, that's 10 meters between the two. That only leaves me 50 meters of fencing to make this side. So really, the width of this barn right here is going to be 60 meters of fencing minus 2 of the side lengths, which are x each. So I can express the width of this barn as 60 minus x minus another x. So the area of this pen is really length times width, which is x times 60 minus 2x. And now I've expressed the area of this rectangular pen in terms of x only, not length and width. Now let's talk about the domain of this function. Remember, the domain of the function is what I can plug in for x. What are my possible values of x? Well, I know for right away that x has to be greater than 0. It can't equal 0, so I'm just going to put greater than 0. I could possibly, if I wanted to, I could make this a half of a meter and this a half a meter. That would be 1 meter for these two sides, and that would leave me 59 meters here, but I don't think that's going to make a very large area for the dog. I also know that x cannot be cannot be more than 30. It must be less than 30. And how do I know that? Well, 2 sides of the barn right here have to add up to less than 60. If I wanted to make this like 29 and 29, that's 58 meters of fencing. That would only leave me 2 meters of the 60 meters of fence to make this side. I don't think that's going to give me a very big area. So I know that my length here has to be at least 0. It has to be more than 0, I'm sorry. And it can't be 30 or anything more than 30. So really, so that means that the values of x have to be in between 0 and 30. They cannot equal 0 or 30 though. So that's the domain, what I can use for x. Okay, to use the graphing calculator to find the maximum value, I first have to go to y equals right here, hit the y equals button, and plug this function in. Make sure none of your plots are on or there's no other functions. You might want to scroll down and make sure nothing is in there. If one of your plots is on, just scroll up, hit enter, and scroll back down and it'll be off. So sometimes when you put a function into the graphing calculator and you go to graph it, you get something that's not very helpful like this. And your calculator by default will go to the standard window where the x-axis goes from -10 to +10. And the y-axis also goes from -10 to +10. You can hit the window button to see if you're in standard window. Not helpful for this graph because I already know that x when x is 0 to 30. I need to go all the way out to 30 before I can see the other zeros of the function. When x is 0, this area is 0. When x is 30, I'll have 30 times 60 minus 60 here, which is also 0. So I know those are the zeros of the function, so I know my x-axis has to go to at least 30. To get an idea of where to set the axis, to set the window for the y values, always look at the table of values. Hit second graph to get to the table of values, and you will get something that looks like this. I'm going to play a video of what I recorded earlier. As you can see, when you go to the table of values, I can see when x is negative numbers that my y values, or the area, is also negative. So that makes sense because we said x has to be more than 0. But you can see as I scroll that it gets bigger and bigger until it gets to about 450. I think I went too fast there. It gets to about 450, and then it starts getting smaller and smaller again. So I know that I want to set my y-axis to go somewhere between 0 and 450. I go a little bit beyond that. I think I set it to like 0 to 500 or something, so we can change the window. So to change the window, what you do is you hit window right here and set the x and y axis to something that makes some more sense. I said x goes from 0 to 30, but I like to see a little bit before 0 and a little bit after 30, so that my parabola isn't exactly in the screen. I want to see it so that it's a little bit in the middle. So a little bit beyond 0 and 30. So go less than 0 and more than 30 a little bit. I set the x scale at 10, which means it's going to put a tick mark on the x-axis every 10 units instead of every 1 unit. And for the y values, I know it needs to go at least up to 450, so I went a little bit beyond that so that my vertex isn't way at the top. It'll be a little bit under. And instead of going from 0 to 450, I went a little bit lower than 0 to negative 10 and a little bit higher than 450 to 500. And you get a little bit better picture when you go to graph. It looks like this. And what you do to find the maximum value is you hit second trace to get to the calculate. You scroll down to the maximum, which is 4, hit enter. And then you have to set your left bound somewhere to the left, hit enter, and it'll put a little triangle there. And then you go to the right side of where that maximum value or the vertex occurs, and you hit enter. And then when you hit guess, it'll give you the values that happen between, it'll have you where the maximum occurs between those two x coordinates. And it looks like when x is about 14.999 repeating, better known as 15. Remember, our calculate round, it really should be 15. When x is 15, the maximum area of this dog pen is 450. So 450 square meters is the maximum area of this dog pen, and that occurs when x is 15 meters.